Hello and welcome to this presentation on impact-based warnings. My name is Jeff Orock and I'm the meteorologist in charge of the National Weather Service office in Wakefield, Virginia. Special thanks to Warning Coordination Meteorologist Bill Samler for the creation of the slides used in this presentation. Impact-based warnings is a simple but important change to the existing warning system in the post-dual pol radar era. Part of the process is to improve the usefulness and effectiveness of both severe thunderstorm and tornado warnings. At its core, impact-based warnings consist of one change in two parts to help designate and communicate risk. There's the addition of a considerable damage threat warning tier within the tornado warnings for significant tornadoes. Significant tornadoes are defined as those of EF2 intensity or greater. There's also the addition of concise wording on conditional impacts or risk that's commensurate with the damage threats. The overall format of severe thunderstorm and tornado warnings has not changed as we continue to communicate risk by defining the hazard character, exposure, and vulnerability. Hazard character is defined as the likelihood of an event occurring, whether it has been indicated on radar or there is a confirmed tornado on the ground. Impact-based warnings greatly expand our ability to communicate the expected magnitude and intensity of the event. Exposure is defined as the pathcast, providing locations to be impacted by the storm and the time the storm will arrive. Vulnerability is known as the impact statements, allowing us to communicate the degrees of damage that may occur. The rationale behind impact-based warnings is that tornadoes are like any other hazard, and they require expressions of predicted magnitude to help establish risk and elicit the most appropriate actions. The National Weather Service has been using the tornado possible tag within severe thunderstorms for several years now. The use is optional. The forecaster will use the tornado possible tag within severe thunderstorm warnings when rotation within the storm is weak and broad, but the environment supports a possible quick tornado development. The tornado tag within severe thunderstorm warnings can also be used for potential weak tornadoes when the occurrence of the tornado may be below the temporal or spatial resolution of the radar. A good example of this is of weak waterspouts developing over the bay, moving onto land. An example of the application of the tornado possible tag within severe thunderstorm warnings, this severe thunderstorm warning utilizes the new impact-based warning structure. Within the severe thunderstorm warning itself, you see the definition of the storm's location and motion. Storm located over Pine Ridge moving northeast at 35 miles per hour. The hazards are explicitly listed within the severe thunderstorm warning as 60-mile-per-hour winds, gust, and quarter-sized hail. The source is radar indicated, and you see the expected impacts from the thunderstorm. At the very bottom of the thunderstorm warning, you will notice that the tornado possible tag has been added by the forecaster to the warning, allowing the communication of a possible tornado within this severe thunderstorm. You also see the hail defined as 1 inch in diameter and winds of 60 miles per hour. Now, within tornado warnings, the conditional tags for tornadoes have been expanded dramatically. Tags are used within the warnings to help provide quick information on the type of hazard and the potential hazard magnitude. Impact statements are embedded within the warnings to provide high-intensity clues for especially dangerous situations. These are known as conditional statements. The table on the right-hand side provides a list of the tags which can be used within tornado warnings. The first tags define the likelihood of the event occurring. Again, this is known as radar indicated or observed. For a tornado to be defined as observed, a confirmed report of a tornado could be received by the National Weather Service from a reliable source. Another way the National Weather Service can confirm a tornado is if tornadic debris is detected by the radar. We'll show some examples of this. Tornado damage threat tags will also be used within tornado warnings. The use of no tag occurs in a generic tornado warning where the circulation may be weak or broad, but there is a good likelihood of a tornado. When conditions warrant and a significant tornado is much more likely, a considerable tag will be used within tornado warnings. The considerable tag threat within the tornado warning is really used to help alert for high impact tornadoes. The target range for the considerable tag are tornadoes of EF2 intensity or greater. There will be enhanced conditional impact statements which will kick in these situations, providing needed high-intensity clues for end users and partners. Radar signatures are the primary method for distinguishing between significant tornadoes and smaller tornadoes. The use of the catastrophic conditional tag within tornado warnings is optimally used only when a violent tornado is striking or posing a threat to a population. The use of the catastrophic tag replaces the tornado emergency. Tornado emergencies were used during events where violent tornadoes of EF5 or greater were confirmed on the ground. Because of this, the use of the catastrophic tag will be exceedingly rare and only used when a confirmed violent tornado is posing a threat to a population. The false alarm rate for tornado warnings with a catastrophic tag should be near zero, for again, the tornado needs to be confirmed on the ground and violent. So again, radar data will be the primary warning decision tool for these tornado warning tags. The use of the considerable tag in tornado warnings allows a forecaster to ring the bell a little louder when significant tornadoes of EF2 intensity or greater are likely. The tornado warnings themselves are not explicitly forecasting the tornado intensity, it's just the likelihood of a significant event is increasing due to the radar signatures. Looking at the table on the right-hand side, the whisker plots here for supercell tornadoes ranging from EF0 upwards of EF4. The whisker plots represent the rotational velocity measured within the supercell's updraft. For EF2 tornadoes, you'll notice the average rotational velocity is around 50 knots. For EF1 tornadoes, the average rotational velocity within the supercell is around 40 knots, and for EF3, upwards of almost 65 knots. For this reason, the average rotational velocity of around 45 knots will be used by the forecasters when considering the use of the considerable tag within the tornado warnings themselves. You will notice that there is overlap between the EF1 tornado intensity, upwards of about 50 knots, and the EF2 tornado intensity down to around just below 45 knots. So again, the 45 knot threshold is a good verifying threshold for the use of the considerable tornado warning tag. In contrast, within quasi-linear convective systems, or QLCSs as they're known, better known as squall lines, the rotational velocity for EF2 tornadoes is quite a bit lower. You'll notice here that EF2 tornadoes occur within squall lines at an average rotation of less than 40 knots. So again, for this reason, the rotational velocity of around 45 to 50 knots is the trigger for the use of the considerable tag within tornado warnings. Taking a look at verification, 32% of all tornado warnings issued with no tag where the rotation was less than 45 to 50 knots resulted in a tornado. This means that 68% of all tornado warnings issued when the rotation was weak resulted in a false alarm. In contrast, 74% of all tornado warnings issued that included a considerable tag where the rotation was in excess of 45 knots resulted in a tornado. The false alarm rate in these instances dropped to 26%. 65% of all warnings issued with a considerable tag resulted in at least an EF1 tornado. Nearly half of all the tornado warnings issued with the considerable tag did indeed result in a significant tornado of EF2 intensity or greater. So based on the study and verification, this does imply that the considerable damage threat tag can be used as an indicator of confidence that a tornado will occur. It is worth noting that the National Weather Service tornado warning false alarm rate has primarily been the result of attempts to warn for very low-end tornadoes of EF0 to low-end EF1 intensity. Taking a look at a case study in Washington, Illinois, you see a long track tornado peaking at around EF4 intensity. At the initial touchdown, you'll notice the rotational velocity was increasing and had reached 55 knots. The 55 knot rotational velocity threshold exceeds the 45 to 50 knots needed for the inclusion of a considerable tag within the tornado warning. Later in time, you'll see the gate-to-gate rotation has increased and the rotational velocity within the circulation has increased to 82 knots. Again, EF4 tornadoes have an average rotational velocity of around 80 knots. Later on in time, the circulation within the supercell weakens and actually becomes more broad, and in fact the tornado is weakening and about to lift off the ground. So showing some examples of impact-based tornado warnings and how they may progress in time, here's the initial issuance of a tornado warning where the circulation within the supercell was less than 45 knots. You'll notice here we continue to provide the location of the thunderstorm that may produce a tornado was near Pekin and moving northeast at 55 miles per hour. The hazards are explicitly defined as tornado and quarter-sized hail. The source at this point is radar-indicated rotation, and we have impact statements mentioning the possible damage to mobile homes and other structures. At the bottom of the tornado warning, you will notice the tags indicate that the tornado has been indicated on radar, and hail may be 1 inch in diameter. A little bit later, a phone call comes in from an emergency manager that they have a tornado on the ground. At this point, a severe weather statement is issued for the tornado warning, updating the conditions. Notice that a confirmed tornado was located near East Peoria. The hazard has been changed to a damaging tornado, and the source, emergency management confirmed tornado. At the bottom of the warning, the tag has also been updated to say tornado observed. Just a few minutes later, the rotational velocity within the supercell increased to greater than 45 to 50 knots. At this time, another severe weather statement is issued updating the tornado conditions. Notice here at 11:03, a confirmed large and extremely dangerous tornado was located near Washington. The inclusion of the wording, "This is a particularly dangerous situation," occurs with the use of the considerable tag due to the increased rotation. The hazard damaging tornado, and the source continues to be emergency management confirming the tornado on the ground. You will notice that the impact statement has also been updated. It now states that you are in a life-threatening situation and that mobile homes will be destroyed. The impacts also convey considerable damage to homes, businesses, and vehicles. At the bottom of the warning, you'll notice that the tornado continues to be observed and the tornado damage threat tag has been upgraded to considerable. Bringing this a little closer to home, we will use the case study from February 24th of 2016. This was an EF3 tornado which developed near Tappahannock, Virginia. Early in the event, as the storm passed by Richmond, Virginia, here at 2306 Zulu, the rotational velocity within the supercell had reached 71.5 knots. The rotational velocity is calculated by sampling the outbound winds represented in red as well as the inbound winds. The use of a considerable tag within a tornado warning would be applied at this point due to the 71 knots of rotational velocity. Once again, the threshold required for the use of the considerable tag within a tornado warning is around 45 to 50 knots, when an EF2 or significant tornado is very likely. This circulation was occurring well before the initial touchdown. A tornado warning that would have been issued for the Tappahannock area with the use of impact-based warnings may have looked like this. Notice that the hazard is defined as a damaging tornado and that the radar is indicating a possible tornado. This would be a particularly dangerous situation. The source would be radar indicated and the impacts would be beefed up, informing folks that they were in a life-threatening situation due to the likelihood of a significant tornado. You'll also notice at the bottom of the warning, the tags would be added indicating that the tornado at this point was being indicated by radar, but the tornado damage threat is considerable due to the intensity of the circulation. A little later in time, as the storm starts to move into King William County, you'll see the rotational velocity 70 knots, and the gate-to-gate rotation has also increased. So the circulation has become much tighter and better defined. Once again, the 70 knots exceeds the needed 45 to 50 knots required for the use of the conditional tag within the tornado warning. Following the tornado touchdown, the rotational velocity does weaken and become more broad. However, the rotational velocity remains around 48 knots, meaning the forecasters would continue to apply the considerable tag within the tornado warnings. Just a little later at 23:43 Zulu, as the tornado is approaching Tappahannock, we are experiencing major damage at this time. The low-level rotation has increased to around 62 knots, and once again the gate-to-gate circulation has tightened, meaning that the circulation is becoming much tighter and much better defined. Statements updating the tornado warnings and future tornado warnings themselves would continue to use the considerable tag mentioning a particularly dangerous situation. It is also worth noting that the circulation was well defined and even reaching the considerable threshold well before the initial touchdown. At this stage, we were also starting to see tornadic debris at the radar beam elevation. You'll notice very low correlation coefficient values here represented on the dual pole. Correlation coefficient relates the horizontal and vertical radar signatures. In situations where tornadic debris is very irregular shaped, the correlation coefficient is very low. So anytime we see low correlation coefficients in areas of very intense circulation, we can assume tornadic debris is reaching the radar beam elevation and the tornado is on the ground. A tornado warning at this point might look like this. This is a particularly dangerous situation. The hazard is a damaging tornado, and there is a radar confirmed tornado. Once again, the impacts do state that people are in a life-threatening situation and that there will be very significant damage. At the bottom of the warning, the tornado tag will state that the tornado has been observed, and the tornado damage threat in this situation does remain considerable due to the intense circulation. Just a little bit later in time, the circulation does become a little bit weaker and more broad. However, it does still exceed the 45 to 50 knots required for the use of the considerable tag within the tornado warning. You will notice that the correlation coefficient continues to become much better defined with very low values and a growing area of debris. Some concluding remarks: impact-based warnings have been initiated throughout the National Weather Service as of mid-April 2016. This provides the opportunity to import dual pole information directly into our warnings via impact-oriented statements and tags. A word of caution on the frequency of use: the meteorology of the situation and the near storm environment will determine how frequently the considerable tag is used, as well as storm consistency and the history of the storm. In other words, a storm briefly reaching a rotational velocity of 45 knots and then quickly dissipating may not warrant the use of a conditional tornado warning tag. In contrast, a storm which increases its rotational velocity to 45 to 50 knots and persists for several radar scans would necessitate the inclusion of a considerable tag within the tornado warning. Once again, thanks for listening to this presentation. For any questions, feel free to email Bill Samler or myself, Jeff Orrock.